Hello everyone, welcome to Maths IEC. Here's another proof question. This is a relatively easy one, but you can still get this question. Prove that the sum of the interior angles of an n-sided polygon is 180 times n minus 2. Please pause the video and try this question. When you want to check the answer, press play. Before we get to the actual proof part, let me explain something using a couple of different polygons. So if you think about a triangle, the number of sides 3, the number of triangles is just 1. What about a quadrilateral, a 4-sided shape? There are 4 sides. Now if I split it starting from one end, I can say that there are 2 triangles. So the number of triangles is 2. What about this one? Number of sides, it's a pentagon, so 5. If I split it starting from here, like that, I can see that it has 3 triangles. What about a hexagon? 6 sides, and the number of triangles is 1, 2, 3, and 4. Now, there is a relationship between the number of sides and number of triangles. So when you have 3 sides, 1 triangle, so that's 2 less. 4 sides, 2 triangles, again 2 less. 5 sides, 2 less, 3. 6 take away 2 gives you 4. Now, if you continue this pattern, obviously, I can understand when I have n number of sides, the number of triangles will be 2 less than n, so it's n minus 2. Now, we can use this fact to do the proof. So we can start to write it like this. Number of sides of a given polygon is n. The number of triangles that you can inscribe in it is n minus 2. Now we know the sum of interior angles of each triangle is 180. So to find it for n minus 2 number of triangles, obviously I have to multiply them. So here is the final answer.